Have you ever wondered about the significance of a simple point in the grand scheme of mathematics? A point, one might say, is nothing more than a tiny dot, an insignificant speck. But in the vast universe of mathematics, a point is so much more. It's a fundamental building block, a cornerstone on which we construct the complex edifices of mathematical theories. The concept of a point, primitive though it might seem, is the starting point of geometry, a field that has shaped our understanding of the world and beyond. It's a concept that has stood the test of time, from the ancient Greeks to the modern mathematicians of the 21st century. As we journey through this video, we will explore the intriguing role of a point, its function in creating shapes, and its relevance in modern mathematics. So, are you ready? Let's delve into the fascinating world of geometry to find out. A point, in the realm of geometry, might seem like a simple concept, but it has profound implications. Let's delve into what exactly a point in geometry is. Imagine you're in an infinite space, a blank canvas that stretches in all directions. Now imagine marking a specific spot on that canvas. That mark, that precise location, is what we call a point. A point is the most basic unit in geometry. It's a fundamental concept that forms the foundation of all other geometric concepts. But here's where it gets interesting. A point has no physical dimensions. It has no width, no length, and no depth. You might be wondering, how can something exist without dimensions? Well, in the abstract world of geometry, it can. You see, a point is not a physical object. It's an abstract concept that helps us understand and navigate the spatial relationships around us. It's a way for us to say, here in this infinite space is a specific location. Yet, despite its lack of size, a point is not nothing. It's a precise location, a placeholder, a marker. It's a way for us to start making sense of the space around us. It's the starting point for creating lines, shapes, and all other geometric constructs. In essence, a point in geometry is like an atom in the physical world. Just as atoms are the building blocks of matter, points are the building blocks of geometry. They are the smallest units that, when put together, make up the lines and shapes that are the language of geometry. So, while a point may have no dimensions, it's far from insignificant. Its existence allows us to construct a geometric framework, a way to understand and navigate the world around us. It's like the dot on a map that says, you are here, a reference point from which all else follows. A point, therefore, is the fundamental building block of all geometric shapes. It may be small, it may be dimensionless, but without it, the world of geometry as we know it would not exist. So, the next time you think of a point, remember, it's not just a dot on a page, it's a cornerstone of our understanding of space. Now, imagine the power of these tiny, sizeless entities when they come together. Have you ever pondered about the might of minuscule points in the colossal expanse of geometry? Well, it's time we delve deeper into this fascinating concept. Points, when connected, form lines. Just like a painter's brush strokes on a canvas, each point serves as a crucial link in the creation of lines. And these lines, they're not just mere connections. Instead, they are the foundational pillars of geometry, the building blocks of all shapes and forms. Think about it. The square you see on your computer screen, the triangle in the logo of your favorite brand, the circle that makes up the wheels of your bicycle. All of these shapes are a result of lines coming together at certain points. And these points, they're not arbitrary. Each point has a distinct identity, a precise location on the plane of geometry. This is where the concept of coordinates comes into play. Coordinates are like the home address for points, telling us exactly where a point resides in the geometric plane. They're the reason we can recreate the same shapes, time and again, with mathematical precision. Now, let's take a moment to appreciate the beauty of this intricate system. The points, the lines, the shapes, all working in harmony, creating a symphony of geometric perfection. It's like a dance, where each point knows its place, each line knows its path, and together they form shapes that are familiar, comforting, and essential for our understanding of the world around us. So you see, points are not just dots on a paper. They're the seeds from which the tree of geometry grows. They're the silent players making their mark wherever lines meet and shapes form. They are, quite literally, the points where geometry begins and ends. In essence, without points, we would have no lines, no shapes, and hence no geometry. So, what makes these seemingly simple points so relevant in modern mathematics? Dive into any branch of modern mathematics, be it calculus, algebra, or analytical geometry, and you'll find points playing a starring role. These tiny, dimensionless entities with no size, no width, no length, and no depth are the building blocks of all geometric shapes and lines. In calculus, the study of change and motion, points are used to define limits and infinitesimals. These are key concepts that enable us to calculate the slope of a tangent line to a curve at a given point or determine the area under a curve. Imagine trying to understand the concept of a derivative or an integral without the humble point. It's like trying to build a skyscraper without bricks. In algebra, points become even more abstract. Here they represent solutions to equations. For instance, in the equation y equals x squared, each point on the graph represents a solution. The x-coordinate of the point gives us the value of x, and the y-coordinate gives us the corresponding value of y. In analytical geometry, points are used to define lines, planes, and other geometric shapes in a coordinate system. They allow us to understand the relationship between algebraic equations and geometric shapes. But the influence of points in modern mathematics extends beyond these branches. They are also instrumental in understanding complex mathematical theories and concepts. Topology, for instance, a branch of mathematics that studies the properties of space that are preserved under continuous transformations, uses points to define open sets and continuity. In number theory, points on an elliptic curve represent solutions to specific types of equations, and their properties have profound implications in areas like cryptography. So despite their simplicity, points are anything but simple. They are the foundation upon which we build our understanding of the mathematical world. They are the silent workers, the unsung heroes of mathematics, often overlooked but always essential. Points, though simple, form the basis of complex mathematical concepts and theories.